Okay, let's see homologous series. So a homologous series is a group of similar compounds with similar properties due to the presence of similar functional groups. That's the definition of a homologous series. But put simply, it's just like a family of compound. So the whole family will have similar properties. They will undergo similar reactions because if we look at the family, everyone has the same surname. So in the case of homologous series, they all have the same functional group. And what is a functional group? A functional group is an atom or group of atoms that give the properties to a molecule. So let's see what it is. So a homologous series, these are the homologous series that we have. So we have alkanes, that's one family. Another family is alkenes. There's an E here. Here there's an A. There's alcohol family. And there's carboxylic acid family. Now, in alkane family, they have something in common. Means that there is all single bonds. Usually, there is in a hydrocarbon. So hydrocarbons, there's going to be C and H only. So in an alkane, so let's say this is an alkene. There's just going to be single bonds everywhere between the carbons, between carbon and hydrogen. Definitely between carbon and hydrogen, there's always going to be one bond. But carbon-carbon can form double bonds. But if it is an alkane, you'll find only single bonds everywhere. So all single bonds. In alkenes, however, there can be double bonds present. There will always be double bonds present. CC double bond is always going to be present in alkenes. So here, so this is one example. So C double bond C. So that's one example. Another example, you have this C double bond C. Single bond with a C, and then filled everywhere with H. Okay, now you have to be careful when you're drawing these kind of structures. Carbon is in group 4 from the periodic table, so it has valency 4, which means that it can form only 4 bonds, and it will form only 4 bonds all the time. It cannot form less than 4 bonds. So if you look at hydrogen, it has valency 1, which means that it can form only 1 bond. This is something that you should always remember when you're drawing. This is called a displayed formula. So when you're drawing a displayed formula, you should keep this in mind. Carbon should always form 4 bonds, always, and hydrogen should always form 1 bond. You cannot have hydrogen forming 2 bonds. So here, you see in my structure, carbon is forming 4 bonds. 1, 2, 3, 4. And if I look at the second one, this carbon, 1, 2, 3, 4. So it's forming 4 bonds. If I look at this one, this carbon, 1, 2, 3, 4. And if I look at this carbon now, here, 1, 2, 3, 4. So you see each carbon is forming 4 bonds and the hydrogen is forming a single bond. Okay, so this, you have to keep this in mind when you're drawing displayed formula. Now, alcohol, it's another family, and in alcohols, there's always going to be OH present. So O is bonded to H, and that O is going to be bonded to something else, usually to a carbon. Okay, so you see, this is an alcohol because it has that OH functional group. Here it has that OH functional group, so it is an alcohol. Carboxylic acid is another family, and in carboxylic acid there is OOH. C double bond OOH. Okay? So here, this is a carboxylic acid with COOH. This is a carboxylic acid with COOH. I've shown all the bonds in this one. Okay, so you see that different families have different groups of atoms that exist in it. And that group of atoms that exist, this is what will take part in reactions, and this is what gives its characteristics to that family. Okay, for example, alkenes, because they have a double bond, alkenes are usually reactive. And because of that OH group here, alcohols are easily oxidized. So you see, different functional group will allow for different kinds of reactions. So it gives the characteristic properties to a molecule. So you have that example here. Let's see if you can identify the functional groups. So all these are alkenes. So you see alkenes, there's the double bond. Alcohols, there's that OH. Carboxylic acid, you see, COOH is always present. Okay? So functional group, what's functional group of alkene? C double bond C. For alcohol, it's OH. And for carboxylic acid, it's COOH. I'll put a bond just here, just to show that this is going to be linked to something. Okay, so these are functional groups. And just to know that a functional group will never exist alone. A functional group will be in the molecule, it will not be alone. So you have that little map, so you can get that in your copybook and complete it. Alkane, for alkane, alkanes don't have a functional group. That's not a functional group. That's just a property that alkane have. Something that you see when you look at alkanes. They are all single bonds. But alkanes, they don't have any functional groups. You can just put a dash there. There's no functional group for alkanes. Now, characteristics of homologous series. So, how are the family members related to each other? So, all members can be represented by a general formula. So, these are examples of general formulas. We'll see that in more detail later on. The successive members differ by CH2. They have similar chemical properties because they have the same functional group. So it's these groups of atoms that gives them the chemical properties. Chemical properties means what reactions will it undergo. So because of that OH, because of that C double bond C, because of that COOH, they will undergo specific reactions. So because they have the same functional group, they will undergo similar chemical reactions. So all double bond C will undergo similar reactions. All COOH will undergo similar reactions. Fourth property, physical properties change in a predictable way. For example, as alkanes become more bulky, their boiling point is going to increase. This is what we see here when we look at all the fossil fuels or the oil fractions. So they're usually all alkanes, and when you look at them, the number of carbon is increasing, so the alkanes get bigger. So when they're getting bigger, the boiling point is increasing. So this is what is meant by physical properties change in a predictable way. Okay, so if I know boiling point of, let's say CH4 is methane is one alkane, C2H6 is another alkane. So let's say I know that the boiling point of this one is minus 160 degrees Celsius, then I know that this one is going to be higher than this. So it's going to be minus 140. So that's a higher temperature. Okay, so you can predict their physical properties. You can predict density, you can predict melting point, you can predict boiling point. These are physical properties. Okay, now let's see naming of organic compounds. So the name of organic compounds tells us two things. The first part of the name, so is going to tell us how many carbons there is in the chain. Okay, so if it starts with meth, there's going to be 1 carbon. If it starts with F, means there's 2 carbon. Prop, 3 carbon. But, 4 pent. 5 hex, 6 hept, 7 oct, 8. So the name tells us how many carbon atoms there's going to be in the compound. You have to know these. Okay? And the second part of the name is going to tell us which family it belongs to, which homologous series it belongs to. If it is an alkane, it will end with ane. If it is an alkene, it will end with ene. If it is an alcohol, it will end with -ol. And if it is a carboxylic acid, it will end with oic acid. Okay, let's see a few examples. So let's say I have methane. Methane has 1 carbon and is from the alkane family. So 1 carbon and an alkane family. Let's say I have ethane. Ethane has 2 carbons, is from the alkane family. There's not going to be any double bonds. So I know there's going to be 2 carbons and there's not going to be any double bonds. So then I can find the structure of ethane like this. We'll do more practice about the structure. Let's say I have propene now. Propene, prop, means there's 3 carbons. Ene means that it is an alkene and there's going to be a double bond between carbon. So then I can draw that. So propene, 3 carbon, 1, 2, 3. There has to be a double bond. Carbon will form 4 bonds. 1, 2, 3, and 4. For this one, 1, 2, 3, and 4. And the last one, 1, 2, 3, and 4. I'm just going to complete the structure using hydrogen atoms. So this is how the names give us ideas about what's in that molecule, what it consists of. Okay, so try these questions. We're going to see the drawings in more details. These questions will just look at the homologous series. Okay.